Welcome to Fantastic Physics. Today I have a very important question, and that question is this. If I take two balls of very, very different masses and I drop them at the same time from the same height, which one will accelerate towards the ground at a higher rate? In other words, which one will fall at the greater rate towards the ground? The very light mass, the very heavy mass, or will they fall at the same rate? So those are your three options. But before I do the demo, let's go ahead and get their masses just so we have some numbers. So I have a scale here. The foam ball has a mass of about 31 grams, so very, very light. This one is a medicine ball, and its mass is 2,138 grams. So 31 grams versus over 2,000 grams. So a very, very big difference in mass. So let's find out which one will accelerate towards this table at the greater rate. So I'm going to get on this ladder here, and I'll go ahead and drop them from this height, and we're just going to see how quickly they fall towards the desk. On 3, 2, 1. All right, so you probably noticed that the foam ball with only 31 grams of mass and the medicine ball with over 2,000 grams, they actually both fell or accelerated towards the table at the same rate. So the rate of fall was virtually identical. However, the medicine ball did hit first, but the only reason it hit first is because when I dropped them, this is a larger object, so the bottom of the medicine ball had a little bit of a head start. But again, if you looked at the footage in slow motion, you could see that they fell at the same rate. And that's because on Earth, all objects, regardless of their mass, will always fall at 9.8 meters per second squared. So the rate of fall for any object is the same when you're on or near the surface of Earth. The only exception to this rule are objects where air resistance is too large to be ignored. So for example, a sheet of paper, when it falls, it actually accelerates at a lower rate than 9.8 meters per second squared because it has so much surface area. That force of the air pushing up on it as it falls is too large, and it has a big effect on the motion of the paper. Okay, so now you probably think you have a pretty good grasp on the rate at which objects accelerate towards the ground, at least on or near the surface of planet Earth. So let's see if I can test your knowledge here. I have a physics textbook, very, very heavy, very massive, and a piece of paper, much less mass, but they both have a pretty similar amount of surface area. They're roughly the same size, at least in this dimension. So I'm going to take these two objects and I'm going to drop them from the exact same height, at least as close as I can get, at the same time. And my question for you is, which one of these objects should hit this desk first? Or which one should fall at the greater rate? Will it be this textbook or will it be this sheet of paper? So take a moment to think, and let's go ahead and check it out and see what happens. Okay, so I'm going to go ahead and drop them from here, and so here I go. And now I have it on 3, 2. Okay, so it looked like they actually did accelerate towards the desk at exactly the same rate. At least their rate of fall appeared to be identical. But you probably noticed that I sort of cheated there, although I never said I was not going to change the shape of that paper, but in this case I did have to crumple it up to get it to fall at the same rate as that book. Because remember, if air resistance can be ignored, then we know things are going to fall at the same rate. And by crumpling this paper up, I'm basically eliminating that surface area and reducing that air resistance to virtually zero, okay? So now the question is, all right, no more cheating. What if I take this textbook and the sheet of paper, and once again, I'm going to drop them from roughly the same height, but I am going to give myself a little leeway here so that, you know, if I decide to drop this paper a few inches lower or a few inches higher than the textbook, so one of them might get a little bit of a head start, but only by, 2 or 3 inches max. But if I drop them at the same time again with that new sort of allowance that you're allowing me to have, which one do you think will hit the table first this time? Or actually, let me change the question. Which one will accelerate towards the desk at the higher rate? Will it be the book, the paper, or will it be the same? So let's get my ladder out and do it once again and see what the answer is. Okay, so I have my two objects and I'm going to go ahead and drop them. Here we go on 3, 2. Okay, so once again, the textbook and this sheet of paper actually accelerated down towards the desk at exactly the same rate, it appeared, right? Neither one of them got further ahead than the other. They sort of fell at the exact same rate together. So at this point, you're probably tired of my tricks, and you know that I'm always leaving information out. So what did I not say this time? Well, I forgot to mention that I was going to drop them stacked like this, but I did say that I would give one of them a sort of a head start in the vertical direction. And it turned out I just let the textbook go before the paper. So why does that cause them to fall at the same rate? Well, it's because if the textbook is underneath, as it's falling, it's the one taking all that air resistance, so the force is acting on this book. But this book has way too much mass, way too much inertia for that small amount of force to really affect its motion. So it basically falls at the same rate of free fall, 9.8 meters per second squared. And by putting the paper behind it, that causes the paper to not directly experience that air resistance. So that air force is pushing up on the book and not on the paper, which allows the paper to also accelerate towards the desk at 9.8 meters per second squared, just like the book. Now, I think you're ready for me to just ask a more straight up and honest question. So let me just say this. This time I will make sure that they're both horizontally apart from each other. So I'm not going to stack them in any sort of way. I will not change their shape in any way. So I won't crumple this paper. No stacking, no crumpling, no more tricks. So which one do you think will accelerate towards the desk this time if I drop them apart like so at the same time from the same position above the table? So let's find out. So let me get on my ladder. And so here we go. I'll drop them from here on 3, 2, 1. And so this time, I think it was pretty clear that the textbook definitely accelerated towards the desk at the higher rate. And so what's the lesson here? Well, I think the first lesson is make sure you get all the information before you make a decision. Sometimes there are people out there that are trying to trick you and have a bit of fun like myself. But the second lesson is all objects, regardless of mass, and I'm talking an elephant, a pebble, a golf ball, me, any object that's in free fall, as long as air resistance can be ignored, they're going to accelerate at the same rate towards the ground, which is 9.8 meters per second squared. Unless, of course, the object is like a sheet of paper or a feather, where the air resistance is now too large of a force, which is going to have an impact on the object's motion, causing it to accelerate slower. The other thing to watch out for is if you're falling from a really high height, then as you fall, you have a really long time to build up speed. And the faster an object is moving, let's say I go skydiving and I'm falling at this point 100 miles per hour. At those speeds, air resistance becomes really, really, really strong, and it's no longer a force that I can ignore. So at that point, it is starting to reduce my acceleration substantially. So that object in free fall, myself as a skydiver, my rate of acceleration is significantly less than an object that's falling from just a one-story building. So it's about the shape of the object, which can change the rate of fall, but it's also about the velocity, and things that are falling from really great heights are going to experience too much air resistance, which will change the result. Thank you for watching Fantastic Physics. Please like this video and subscribe to our channel if you want to see more interesting physics content. Goodbye for now, and remember, it's a fantastic universe out there, so stay curious.